Коллеги, добрый день.
Good afternoon. I'm Artyom Melisov, and today we'll speak about backdoors of the neural networks, and there will be two parts: relevant, non-relevant. And the second part of the report will speak about the experiment we have conducted and some conclusions we have made. If we take neural networks in an account and any AI technology, together with the technological safety, we can interpret these two terms in a different way. AI technologies can be applied for detection of computer attacks, for conducting such attacks, and these technologies of artificial intelligence also have vulnerabilities. Kaspersky Report 2021 reveals different information infrastructure objects having suspicious functionality. And judging from that successful integration of different technologies of AI into industrial scope, that's what started this research. The AI white book on prospective technologies came up, and it can be divided into a few segments. According to applied data, we also have electronic component database. In the Russian Federation, we have growth of the number of research and technical usage of it in different information technology system in telecom networks and different levels with different components. The technologies of artificial intelligence have certain level of trust, so it's the confidence of a user, it's the confidence of an organization in the quality of its performance. And a large share of artificial intelligence accounts for neural networks used these days. The life cycle of the development and the implementation of such a system is shown on the slide. It's quite a complex one. A huge computational and human resource is required for it, yet the personnel should be highly qualified. In the real environment, in the real world, we can see the example of it. Not even a human sometimes tell the difference. So what's going to happen with the neural network? Apart from these complications, there also may be threats. So the regulator has disclosed 5 threat levels according to this technology. Unfortunately, starting from December 2020, they have not been updated, but they are shown on the slide. And I would like to show you which they are. The development of artificial intelligence, machine learning, can be split trivially into 2 phases: training phase, testing phase. So the main elements where the intruder can impact on is, of course, the data, the algorithm, and the model itself. So what I would like to say, it's dangerous not only just to train the model with the backdoor data, but also adaptive training. There are plenty of players in the market who have created such models. So according to our task, we just need to use our data, take it, train it to make it suit its needs. We can take the pre-trained model, defreeze the end layers and train it on our data. So we can effectively use somebody else's model by changing it slightly. At each of these levels, there is a threat of installing a backdoor into our training data. What about this backdoor story? So there may be some misunderstanding. So if we take artificial vision, a trigger is added, like for example, a red pixel is added to some corner. So when there is a call of such a class, it can give a radically different result. At a picture with the trigger, with the pixel, we will be getting a cat. However, the original picture was a picture of a dog. A few dozens of huge organizations are trying to tackle this issue, including Microsoft and Mitri, in other words, has identified the solution as well. And the initiative was taken by the Department of Prospective Studies of the United States Army. They have INXed, Artificial Intelligence Next, in other words. That's the program where they specialize on the safety of the and security of the artificial intelligence, and GUARD. ART and text attack would allow us to carry out attacks on the artificial intelligence technologies. Yet ART would help us attack main frameworks with PyTorch, TensorFlow, and text attack is mainly for various adversary MLP attacks. For 18 months, there's been analysis of different attacks and of technologies of artificial intelligence, CUJOAI. It's a fundamental study. A lot has been done, but let us take which was our approach to reveal a backdoor. We decided to identify the image, and that's the backdoor attack. It's a class of an aircraft marked by a red pixel, like I said previously. How do we install a backdoor? We infect it with a trigger. We add this trigger to the modified images and start training this model. As we train it, the quality reduces. So we take different classification metrics, and they will be all reduced. What was the original idea of how to fight this backdoor? First of all, we just need to reveal it, if there is a backdoor, what's employed or not employed, and then we need to identify this backdoor, what's the format of the trigger in there, and we just need to neutralize it. So we took three sets of data: MNST, handwritten numbers. We took DOTA, DOTA, 15 classes of aircraft imagery, and the set of data regarding the celebrities. So we have access to the trained artificial intelligence neural network. We took simpler solutions and recreated them. So we ended up having three convolutional neural networks, which would give us an average precision for all of the three classes, and that average precision was actually matching the studies that we had originally considered as sources. Therefore, initially we believed that that data that we worked with was safe, and it didn't contain any additional embedded elements, and we have access to the computational resources. For this, we used virtualization, as features are shown on the slide, and we can find something better if necessary, of course. So there may be a question rising here. How many classes will we be infecting? Starting from the time spent on the neutralization, we were trying to infect one class out of 15, 10, 1668. So the sizes of clusters are proportional. So when we were doing it, we were creating approximately 15 or 20 repos, which are helping us to set up triggers, add data, train the neural network. So please take one of the 10 or 20 or 30 repos. The precision of the classification does not differ much. It's pretty good. It's pretty precise, especially for DOTA. So let's go step by step. We reveal the embedded element. We consider the class for the backdoor attack. We synthesize the triggers, and we measure the changing of the deviation of the quality. For each class, we repeat stages 1 and 2, and we identify minimal triggers that are used here. It's the share of the modified data. We added the information here. So we thought, what is the task considered here? The first one is just to be unnoticed, and the second is to carry out the attack successfully. So here we have the graphic characteristics. 2 or 3% are enough just to successfully introduce the backdoors there, so that the quality of our models remains at a very good level. That's for LFF. When we found this model, we just need to identify this model. The identification occurs like this. We measure the average excitement. For the target class, this excitement will be less than for the other classes. Identifying these embedded elements can be done visually, but there is no system available which would run through all of the data and identify the trigger in a big set of data. However, the trend to the data growth exists there. So immediately we take this activation away. And the activation of neurons feature. Why is it used here? For further neutralization. The neutralization happens in two ways. We may take the layer, the end layer, take the units that give us bigger results, having a trigger in place, and we select them and remove them from the layer. The same repeats for other layers. If the quality of the layers, if the quality does not increase. And the next thing is when we cancel the training. It's the so-called fine-tuning, which helps us distribute, recalculate the weights of the neural network before the quality of functioning is not adjusted. So what are the results that we have received? We did not receive the results for the third set of data because there are more than 1,500 classes. It takes a long time, and in the current situation, it's not quite possible. For 10, 15 classes, we received deviation, the aggravation of the quality of the neural network after we canceled the training, so the efficiency of the attack reduced to minimum. Therefore, what kind of conclusions can we make? So, number one, all the AI technologies cost a lot of money, it's expensive, and the way to make them safer, the way I described, is much cheaper than developing a new neural network. And by enhancing the size of it and complication of trigger, the intruder may complicate the synthesis of protection triggers. So I guess it's not suitable here. And in prospect, we can identify a few infected classes, and it will infect not just one class, but maybe more. Thank you very much. I think I should ask you for a couple of questions, or maybe just one. Thank you.